All right, let's take a look at our lesson for today. We are starting a new unit. So exciting. It's called Contextual Applications of the Derivative. Yay. So our first lesson is on straight line motion. Some call it particle motion or straight line motion. And we've got some vocabulary, some concepts we need to talk about before we jump into working problems. First up, we need to talk about what the sign of velocity means. So if velocity is positive, you can see where this right here. So if velocity is positive, what does that mean for the particle? What's happening to the particle? So if velocity is positive, that means the particle is moving right. With particle motion, we're talking about it's a straight line, like moving left and right. Now, in other contexts, you can probably see that if velocity is positive, maybe the context is like an airplane or something, or a hot air balloon. That would be going up. But in the context that we're talking about with straight line motion, we're just talking about right-left motion. So if velocity is negative, that means the particle is moving left. And if velocity is 0, that means the particle is stopped. Okay, so we can learn a lot about what the particle is doing by looking at the velocity equation and looking at the sign of velocity. What's happening? Average velocity, which we have done average rate of change before, it's the exact same formula. Average velocity is the position, which with straight line, they like to, let's talk about position. They like to name them like x of t. That's like how they would name a position, or sometimes they like to name them s of t. That's just the typical name. Instead of f, with functions, we normally name them f or g. With straight line motion, we typically name the positions x of t or s of t. So for average velocity, we would do x of b minus x of a over b minus a. Now, this really isn't a new formula for you to learn. If you would prefer to think of it as f of b minus f of a over b minus a, that is perfectly fine. I have no problem with that at all. You can think about that formula either of those ways. So that's some information about what the particle is doing according to, or being judged by, the sign of velocity. So let's look at another critical point right here. And we've got to be able to tell whether the particle is speeding up or slowing down. Now, I say this every single year, and I don't know why. I'm just telling you, there is only one way to justify slowing up and speeding down, and it's this. Please don't try anything else, like, oh, well, the velocity is positive. No, that doesn't mean that we're speeding up or slowing down. Here's what we have to do. We have to compare velocity and acceleration together. We have to compare the signs of them. So if they have the same sign, like they're both positive or they're both negative, then the particle is speeding up. Okay, so that's the test that we use. We basically look at the sign of velocity and the sign of acceleration at a particular time, and then we make that judgment call. Are they the same sign or different signs? If velocity and acceleration have different signs, then the particle is slowing down. Okay. Displacement in words is end minus beginning. So displacement and distance are different, right? Displacement and distance are different. If I were to stand in front of the projector screen, and I were to move right 2 steps and then left 2 steps, I'd be exactly back where I started, right? So my displacement would be 0. but my distance would not be 0. It would be 4 steps, right? You with me? So they're different concepts. We just need to be sure we have them in our brain. Those are different. And so displacement in words is end minus beginning, and you use the position. So we could, in symbols, we could write as like x of b minus x of a, where a is the end minus beginning, where a is the start and b is the end time. Start time, end time. Okay, so if we wanted to put it in symbols, it would be like x of b minus x of a. So we go back to the position to determine displacement. We look at the position for that, not velocity. All right, so those are the main concepts that we're going to be looking at today. Are there any questions so far? Okay, so let's practice. Let's practice determining whether a particle is speeding up or slowing down. We've got a few different things to practice. So let's see. So on the first one, so we're going to kind of focus on this one right here. This is our time at time 5. We're looking at time 5. And we're judging when time is -5. Now that seems kind of weird to us sometimes. Is it weird for us to have a negative time? That's kind of weird, isn't it? But it's certainly possible. It's okay to have negative time. It just means before, like if we say the end of this class period is time 0. Like when class is over today, that's time 0. Well, then right now we would be in negative time, right? So it just depends on what your focus is. So here, velocity is greater than 0. Here, acceleration is less than 0. They have different signs, so my conclusion is that the particle is slowing down. Okay? Slowing down because they have different signs. Now, if I'm justifying it, I would say slowing down because A and V have different signs. Okay, so let's look at our next scenario. Now we are at a time of 1. Now we're at a time of 1. So when we have a time of 1, we're in positive time now, right? We're in positive time, which is fine, right? It doesn't matter what time is positive or negative. So here our velocity is less than 0 and our acceleration is greater than 0. Okay, so they switch places, but does that really matter? It doesn't, does it? They're still opposite signs, so we're still slowing down. We're still slowing down. And this would be our reasoning for both of these, because acceleration and velocity have different signs. Okay, let's move to this one. So here our time is 2, which is just, that's great. Time is 2. Here our velocity is greater than 0 and our acceleration is greater than 0. Okay, so that means we're speeding up. Okay, so we would say, if we're justifying, we would say because acceleration and velocity have same signs. Okay, now what do you think would happen? I just want to do a what if. What do you think would happen if this number right here were 0? Does 0 have a sign? No, it's the only number without a sign. So we would be neither speeding up or slowing down. That would be kind of messed up, and they normally won't do that. So I'm just telling you, it has to have a sign. We have to have different signs. And 0, poor little 0, it probably hurts his feelings terribly. He has no sign. He's like the only number without a sign. Oh well, sorry 0. Okay, so now the last one, we're looking at this last one. This is where time is 4. And where time is 4, we're looking at, let's see, so velocity is less than 0, acceleration is less than 0. So are we speeding up or slowing down? We are speeding up because the signs are the same. And this justification I would use for both of these. Okay, so that's some practice on speeding up and slowing down. Really important to recognize that the way that we tell is by the sign of velocity and acceleration. That's it. There is no other way to tell. Okay? That's what we're looking for. So what we're going to do next, we've got a couple of free response problems. I know you're going to be so upset to know that there aren't any free response in the AP classroom. I know that's terrible, right? Oh, darn the luck. But we are going to practice because this is a typical like free response question on a test or something, so it's good that we practice them. All right, so the first one, we have a position, or our x-coordinate of a particle is moving along the x-axis, and it's modeled by, which I guess is probably why they named this x of t, because the particle is like moving back and forth on the x-axis. Okay, that's a horrible example of it, but it's moving back and forth and back and forth. So that's, I guess, why they call it x of t, where x is measured in centimeters and t is measured in minutes. Whenever they give us units, we're going to have to use them. We do not have a choice. X is in centimeters and t is in minutes. Okay, so every time we put an answer, we have to put the units by it. Okay, we can't forget that, or we'll lose a point. So just please don't forget that. So the first thing, they're asking us to find the displacement of the particle during the first 2 minutes. Okay, displacement is end minus beginning. Right, and it's my x, x of 2 minus x of 0. That's what I have to do. So it's just like plugging in numbers and calculating. So let's see, we've got 2 cubed minus 4 times 2 squared plus 3 minus. Then I've got 0 cubed minus 4 times 0 squared plus 3. Okay, so that is the arithmetic that I'm going to need to do to determine displacement. So now it's just a matter of arithmetic, which y'all know is not my strength. So help me out here. All right, so 2 cubed is 8 minus, let's see, 2 squared is 4, 4 times 4 is 16, plus 3, and then minus 3. Okay, so those go to 0. Let's see, 8 minus 16, that's negative 8, right? Negative 8. Negative 8, and our units are centimeters. So what does this mean, this negative 8 displacement? Negative means that we are left of where we started, right? We are left 8 units of where we started. That's how we've been displaced. Okay, are we okay with that? Because they're going to ask us to actually interpret our answers sometimes. What does that mean that you're negative 8 centimeters? Okay, that means that during the first 2 minutes, and let's just write it down, during the first 2 minutes, the particle ended 8 centimeters to the left. Okay, so next they want us to find average velocity of the particle during the first 2 minutes. Oh, well, that's kind of neat. We've already done the first 2 minutes here. That's kind of handy. So average velocity is going to be x of 2 minus x of 0 over 2 minus 0. Okay, and we actually already did the calculations. Yay. So x of 2 minus x of 0 was negative 8. 2 minus 0 is 2. So that's negative 4. And this is velocity. Okay, we're average velocity. So our units are like distance by time. So what is it again? Minutes. It's centimeters per minute. Okay. So when we're talking about velocity, let's just kind of, you probably already know, what does the sign of velocity mean? Like in this case, so if our average velocity is negative 4 centimeters per minute, does that mean they're going slow? What does the negative mean? It's a direction, right? It's a direction. It means they're going left. It's a direction. Negative, it's a direction. It's not like saying that they're slow or something. Like 4 is bigger than negative 4. That's not it at all. It's a direction. Velocity has direction and speed, so magnitude and direction. Okay, very good. So find the velocity of the particle when t is 4. Okay, so I'm going to have to shrink this a little bit so I can see. So we need the velocity equation to do that. So I need to find v of t, and we're going to use power rule. So the derivative of t cubed is 3t squared minus the derivative of 4t squared is what? Negative 8t. And the derivative of 3 is 0. Okay, we got that. So I want velocity at 4. So v of 4 is 3 times 4 squared minus 8 times 4. Oh goodness, 3 times 16. 8 times 4 is what, 32? Does anybody know what 3 times 16 is? It's 48, thank you. So 48 minus 32. So 48 minus 32 is what, 16? Thank you. So v of 4 is 16, and it's velocity, so we've got that centimeters per minute going on. Okay, is that okay? So that's the velocity at time is 4. Okay, so now let's look. Part D wants us to find acceleration at 4. So we need the acceleration formula. So are we comfortable with the fact, I just want to make sure we understand. So position is x of t, right? That's position. V of t is velocity, and it's the first derivative, right? Velocity is first derivative. And A of t is acceleration or second derivative. Just want to make sure we're kind of tracking with that. So I have my position. When I take the derivative of my position, I get velocity. When I take the derivative of velocity, I get acceleration. Okay? So that's the process that I do. So to get acceleration, I'm going to have to take the derivative of velocity, which we did. We have velocity down there at the bottom. So let me go back down here and pick that up. So velocity was, what, 3t squared minus 8t. So the derivative of 3t, and I am very visual, so I'm going to have to write it down here, or I'm just going to forget. So velocity is 3t squared minus 8t. So acceleration would be, what, 6t minus 8. And we want acceleration at 4. Uh-huh.
How do you just determine that, like, for this to take the derivative, like it's kind of confusing when you think about physics. What does this actually to do with it?
So in calculus, we model physics concepts with variables and, equations. I assume so. Yeah, I have never taken a physics class. I have taken lots and lots of math classes, but at my high school, we didn't take physics. It was like an option. I guess I opted out. I don't know. It seems fun. I should have taken it, but I didn't. Yeah. So calculus makes physics easier. I'm just going to tell you. Calculus, the use of calculus in physics makes things for them easier. All right, so a of 4 is 6 times 4 minus 8. So what, 24 minus 8? What is that? Is that 16? A of 4 is 16. So I've always found acceleration units are kind of strange. It's centimeters per per minute squared, which is kind of weird to me. That's a weird unit, but that's what it is. It is what it is. Okay. So the last question is the particle speeding up or slowing down at t equals 4? Justify. Now, it just so happens that we just found velocity at 4 and acceleration at 4. Yay! So we don't have to do extra work. That was nice of them. So our velocity was greater than 0, right? It was 16. And our acceleration is greater than 0. It's 16, just weirdly enough, 16 and 16. So what is our answer? I mean, are we speeding up or are we slowing down? We're speeding up. We're speeding up, and it says justify, but even if it doesn't say justify, you need to justify. You've got to justify. So sometimes, they'll put a point with justifying and not even say to justify. So please be sure you're justifying. Speeding up because the velocity and acceleration have the same sign. I would recommend that you just say they have the same sign instead of they're both positive, because what if you got it mixed up and they're both negative? So just to make, just to play it safe, I would encourage you to say they have the same sign or different signs. Okay, so are we okay on this one? All right, wonderful. We have one more to do. This one has a graph. Again, we're just practicing how you will be tested, because you will have a test question, certainly kind of just like this. So the figure shows the velocity of a particle moving on a line. So let's make sure we are clear that this is velocity. Okay, we're reading this as a velocity graph, and it shows you right here, it's velocity. We would read graphs differently if they were velocity versus if they were position. So really important to make a note, a huge note. Okay, so when is the particle moving right? Let's think back to our rules. You have to know the rules to be able to answer this. So how do we tell if a particle is moving right? It's by the sign of velocity, right? What is the sign of velocity when the particle is moving right? It's positive. So when we look at this graph, we're looking at where it's positive, where the y values are positive. They're here. This is a picture. This is a picture of velocity, and it is a picture of all of the y values of velocity between 0 and 7. And so we're looking here and we're seeing that velocity y values are positive between 0 and 1 and between, what does that look like? Maybe 4.5. We'll just round it to 4.5 and 7. That's when the velocity is positive. So that's when the particle is moving right. So we would say moving right between 0 and 1 and 4.5 to 7 because v is greater than 0. That's our justification. Okay, when is the particle moving left? So thinking back to the rules that we would have memorized, the particle is moving left when velocity is negative. So I'm looking over here, I'm looking for the y value to be negative. Okay, the y values are negative here. So this is where the particle is moving left. So here we go. So particles moving left between, so we'll just write it out, moving left between 1 and, 4.5, because velocity is less than 0. See, it only takes me like a second to write the reason, because velocity is less than 0, and that can earn me a point. So just take the extra second and write that down. When is the particle's acceleration positive, negative, and 0? Ooh, okay, they're talking crazy talk now. Acceleration. How in the world am I going to read acceleration off of a velocity graph? It's the slope. Absolutely, it's the slope. So, because think about that, the velocity is the first derivative and acceleration is the second. So I'm looking at slopes. All right, so let's look at this slope. We've got this going on. That's negative, and that's a negative slope. And what were they asking? Let's make sure. We want to know, positive, negative, and 0. They want to know both. Okay, fine. We'll do positive first since they said positive first. Okay, here we've got acceleration. This is a positive slope. It's a positive slope on velocity, so between 2 and 6. Okay, so acceleration is positive between 2 and 6 because acceleration is greater than 0. Now, when we get to other uses of this, we're going to have to use a different technique. I'm just saying for justification, which is probably why they're not asking us to justify. But I just want to have it in our head. How do we know that? Because acceleration is positive. The slope of velocity is positive. Okay. Whereas acceleration is negative. Okay, so let's look back over here. So let's see, we're negative here and here. So what is that? 0 to 2 and 6 to 7. So the acceleration is negative from 0 to 2 and 6 to 7. And you can put a U in there if you really like that kind of notation, or a comma. It doesn't matter, because acceleration is less than 0, or the slope of velocity is negative. Acceleration being 0. Acceleration being 0. What do you think? When would acceleration be 0? Yeah, there's nothing going on at the corners, right? That's not positive or negative. So we're going to say acceleration is 0 at t equals 2 and t equals 6. And we don't know what's happening after 7, so we can't do that. And I'm going to leave a justification off of that. I'm not going to talk about that. Okay. So when does the particle have the greatest speed? Let's think about this for a second. This is velocity, and this is the y values of velocity. So for example, at this location right here, the speed is 1. And it's what the unit, centimeters per minute, 1. Right? How do I know that this is a speed of 1? Because that's the y value at 1, right? Or the y value at 6 is 1, so that's a speed of 1. It wants to know the greatest speed. And it's asking when. When do we have the greatest speed? So what is the very biggest y value? What's the very biggest y value? 2. I have 2 here, and I have negative 2 here. What is that going to make a difference? It's just direction. Yeah. So, I mean, there's 2 times where the speed is the greatest, right? The speed is greatest at 0, at time 0, and at time 2. Okay, so let's write that down. So greatest speed is 2 centimeters per minute, occurs at t equals 0 and t equals 2. Well, I guess I should put plus or minus 2 centimeters per minute, because one time it's plus, one time it's minus. But that's just direction, it's not magnitude. Right, so that's when we have the greatest speed. All right, so now we're talking about, speeding up and slowing down. Well, speeding up and slowing down, I need to compare velocity and acceleration. Now, the easiest way for me to compare is with a sign chart. And I don't know, y'all don't have to do sign charts, but I'm going to. I'm going to do a sign chart. So I'm going to do a sign chart, a velocity sign chart up here. So this is my velocity sign chart. This is my velocity sign chart, and this is where velocity is 0, right, where I'm putting these marks. So that's 1, and that's 4.5. Okay, and then that's 7. Okay, we don't know what's going on there or there. We don't have any idea. Okay, so velocity is positive here, negative there, and positive there. Okay, are we okay with that? Now, I like to do a sign chart on acceleration because it just would drive me crazy to have to look at the graph over and over and over again. So I'm going to do a sign chart on acceleration. And my points here are when the slopes are changing. So that's at 2, and that's at 6. Okay, and of course, we're stopping at 7 and at 0. All right, so let's look at the sign of acceleration. Okay, the sign of acceleration. So this is a negative slope, so my acceleration would be negative right here. Okay, this is a positive slope between 2 and 6, so my acceleration will be positive here. And then this is a negative slope. Okay, so now what am I going to do? Well, what I have to do is I have to compare the sign charts. Okay, now this is where students get confused. I don't know if this is going to help or not, but I'm going to draw lines. This is what we need to think through this. Okay, everywhere there's a number, there is a line all the way down. Okay, everywhere I have a number, I have a line. There's a number here. There's a number here. Okay, those are the sections that I have to pay attention to. Everywhere there's a number. Okay, so let's make our judgments here about what's happening. So I'm actually going to just list them. Are we okay with that? I'm just going to list them we're going to classify all of this stuff. So between 0 and 1, I'm looking at this section right here, between 0 and 1, I've got a positive velocity and negative acceleration. Am I speeding up or slowing down? I've got positive velocity and negative acceleration. I'm slowing down, and I'm just going to put an arrow like that so I know that that's down. I'm just making myself little notes is all I'm doing. All right, so now between 1 and 2, I've got negative velocity and negative acceleration. So I'm speeding up. Okay, with me? This is the part where students get kind of lost, where we're comparing the sign charts to each other. I'm hoping we're okay. Okay, now I'm going between 2 and 4.5. Between 2 and 4.5, I've got negative velocity and positive acceleration, so I'm slowing down. Between 4.5 and 6, I've got positive velocity and positive acceleration. I'm speeding up. Y'all see what I'm doing? Okay. Between 6 and 7, I've got positive velocity and negative acceleration, so I'm slowing down. And they don't always alternate like that. I mean, that just happens to be how they're doing it right now, but they don't always alternate like that, exactly like that. So let's do our results. Speeding up. Speeding up is between 1 and 2. Where else are we speeding up? Between 4.5 and 6. And that's the only two, right? Those are the two speeding up, because acceleration and velocity have the same signs. Now, if you actually say what the sign is, you're going to have to do a justification for each one of those. So I recommend you just say they have the same signs. Same. Okay. So slowing down. Okay, so let's look at down. So it's between 0 and 1, down between 2 and 4.5. Where else? And then between 6 and 7, because acceleration and velocity have different signs. Okay, and that is it.